often misunderstood parts counting operation is average piece weight optimizing. Using automatic optimizing makes it possible to increase the accuracy of the average piece weight calculation, which in turn will increase counting accuracy under certain circumstances. The best use of APW optimizing allows smaller parts to be counted on higher capacity scales without excessive hand sample counts. The operation requires a small initial hand count and then allows the scale to automatically update the average piece weight as additional parts are slowly added. The process is simple and can substantially increase count accuracy as long as the parts maintain near 99% uniformity. There are a couple of menu options that need to be modified in the Midrix 2 indicator before we begin. First of all, we need to deselect option 9 or 3.9.1. We need to enable either options 3.9.2, .3, or .4 as increased internal resolution is necessary to calculate the average piece weight more accurately. Second, we need to be certain that average piece weight optimizing has been enabled. By default, in the Midrix indicator, option 3.12.3 is enabled, but it's a good idea to check and be certain that the change has not been made to the menu. One thing that is very important, APW optimizing will not increase the accuracy for non-uniform parts. For extremely non-uniform parts, there is no good option, but the best chance is to disable the optimizing feature entirely with option 3.12.1 and then enable option 3.9.1 that you see above. For this example, we're going to compare the difference in accuracy from a non-optimized initial sample to an optimized initial sample. First of all, we've selected a scale with 30,000 grams capacity and a 1 gram readability. For purposes of testing on this particular scale, we're going to use 5 pieces. Each piece is slightly less than half a gram. To start the count, press 5, weight reference, and then we'll begin to fill our known quantity on the scale. In this case, we have between the sample and the bulk 354 pieces. The indicated count has a variance of 11 pieces at 3.1% error. Now we'll clear the samples off and we'll try to count using the auto sample optimization. We do so using the same 5-piece sample we used previously. Once loaded on the scale, press OK, and the initial average piece weight has been established. Again, we have an actual count of 354. This time we're going to add a few pieces at a time and allow the scale to optimize the average piece weight as we increase the sample size. We'll do this several times until we get to about 40 or 50 pieces. And then we'll load the entire bulk, the same 354 that we had in the previous test. Now this time, as you can see, the count is much better. We have a variance of just 2 pieces for an average error of 0.5%. So there's no doubt that count optimization can help, especially with very small samples on larger scales. There are a couple of notes during the operation that you need to be aware of. Optimizing will stop when added samples are greater than the previous count. That means if you've optimized 25 pieces and add 30 pieces, the optimization will be suspended and you'll continue counting without optimization. The second circumstance can occur if you're weighing very inaccurate or non-uniform parts. The optimization will stop if the scale detects a significant change in the average piece weight from the previous optimization, and again continue the counting operation without the optimization turned on. The optimization is automatically reset when you start over with a new part. This concludes our demonstration of count accuracy with and without optimization. If you have questions, please give us a call. We'll be happy to walk you through the menu setup and any questions you have about parts counting.